Hello everyone, welcome back to another DevOps Cloud Native and Kubernetes video. Today I'm going to talk about how we can use open source security tool Falco in combination with Azure Kubernetes Service and Azure Sentinel. So if you talk about securing your containerized environment, we can use different approaches like using hardened images or use security scanning tool, image scanning tool to scan images, containing images for any vulnerabilities. But the question is how we can secure the container runtime, how we can identify if there are any malicious activities happening when the container is running inside the cluster. So that's why we had to use a security tool like Falco. So Falco is a runtime security tool which we can use to identify any malicious activities when your containers are running. So Falco is an open source tool and it is a part of CNCF landscape, and it is widely popular within the security community for identifying any runtime attacks or monitoring runtimes in Kubernetes. So for this session, I will use Falco and run Falco on AKS. Then I will extend the capabilities of Falco into Azure Sentinel. If you are not familiar with Azure Sentinel is a cloud SIEM, security incident management system, so that can analyze different logs and correlated any attacks and create different incidents based on those correlation between different logs. So Sentinel can be integrated with many connectors, right? So such as Azure Active Directory logs and your application logs, and if you have any other third-party application, also they have connectors, or you can use even you can send your router logs and network routing endpoints logs as well. So there are different capabilities and different methods that you can send logs into the Azure Sentinel. So it's like a central location for your security analysis to identify any threats within your organization. So in this demo, I will show you how we can send Falco logs or the AKS runtime detections through the Falco to Azure Sentinel. So this is a diagram here. So here you can see what components we are going to use. Falco is open source, so security tool we are going to install in the AKS cluster. Then you need AKS cluster. Then I will create a logic cap for HTTP webhook to receive Falco alerts. Then from that logic cap, it will ingest that Falco events to the Azure Log Analytics workspace. Then Azure Log Analytics workspace is Azure Sentinel is based on Log Analytics workspace, so you will enable Azure Sentinel on top of Log Analytics workspace. So in this simple diagram, you can see you have your workload pods, right? Then you have your Falco running as a daemon set, and we are using Falco Sidekick, which is a component of the Falco which used to send the Falco events to different outputs, in the sense it can be a webhook, it can be a event hub, it can be storage account, or there are many options available in Falco Sidekick. So if you go to the Falco Sidekick documentation, you can find many output methods you can send Falco events. Then in this scenario, we will use logic app with HTTP webhook. Then we will create the logic app, and we will include the webhook endpoint to the Falco Sidekick to send the data to the logic app. Then the logic app will trigger based on the HTTP post request. Then in the logic app, it has different steps. So it will go and ingest the events to the Sentinel enable log analytic workspace through the data collection API of the log analytic workspace. Then in Azure Sentinel is connected to the log analytic workspace. Then we will create some detection rules in Azure Sentinel. Then the detection rules will detect any malicious activities, and will create an incident based on the detection rule. So this is the high level overview. So we will go and see how we can provision this environment, right? So in this README, you can find many information about the demo setup, right? So you can find some KQL queries as well. So yeah, let's go and deploy the setup and see how it's going to provision. Okay, for your convenience, I have created the bash script. So it is under the script section. You have the deploy.sh, and you have the PowerShell version of it as well, right? Then I have another script to create some simulation attacks, right? So then you can use the simulation attacks sh to spin up some containers and do different attack types. Then we use bicep. So in the bicep, in the biceps, you can find the main.bicep as a modules approach. So in the modules folder, you can find the cluster, log analytic, and logic app modules, right? Then under the gates, you can find the Falco installation as well, right? So this main.bicep will call the modules to deploy these different Azure components, right? Then from the deployment sh file, deployment script, it will create the namespaces. Then you have the Falco values file, and it will go and provision it will deploy the Falco into the cluster. So you can see that I'm enabling Falco Sidekick, right? So this webhook, this is the place you need to add the webhook, but this will be set by the deployment script, right? So it will get the webhook URL, webhook HTTP URL, then it will replace it. So if you take a look at the deployment sh, right? So it has a prerequisite check, then log into the Azure, then it will provision the infrastructure that need for our environment, Azure infrastructure. It will use the bicep file we have specified, right, and the parameter file. Then it will get the outputs of the deployments, right? then there's a function to get the webhook URLs, right? So calling the REST API of the Azure Logic App. Then it will get the credential of the cluster. Then it will install the Falco and replace the webhook URL with the when you deploy the Helm upgrade. Then it will verify the Falco is installed. Then it will wait until the logs are generated in the Falco, right? Then it will run some warm-up container to generate some logs, because we are creating a custom table in log-analytic workspace. To create that custom table automatically we need some logs. So yeah, then it will monitor that space. Then it will go and deploy the Sentinel analytic rules, and you can find those analytic rules in the Sentinel rule JSON. So there are basically KQL queries and description and those kind of thing. So it will go and deploy these analytical queries as well. Then at the finally it will deploy the workbook created. So this workbook is created to monitor view some security events, right? So it will deploy the workbook, then you will see a count of patterns of different security events. So the workbook can be found in the workbook folder. It's a JSON workbook, right? So it contains different KQL queries to query the data for the workbook, right? Okay. So let's go and provision this and see how it's going to provision. I will use deploy.sh. Okay. Then it will provision the infrastructure. So this will take some time, like 5 to 10 minutes. So we will come back after the Azure resources are provisioned. Okay, after about 10 minutes, you can see that all the components that are needed for us in Azure is provisioned. It includes AKS cluster, logic app, log analytics workspace, and enabling the Sentinel as well. So after it is completed, it will connect to the Kubernetes cluster. Then it will create the namespace for Falco, and Falco will be deployed through the Helm. Then it will wait until the Falco is provisioned, right? So then all the Falco components are running. Then it will wait until the Falco sends some events, right? So after few minutes, you can see the Falco is send some events to the log analytic workspace table. Then it will create the Falco analytical rules in Sentinel. Okay. Then you will see at the end you will see a deployment summary. So you can go and run some commands, KQL commands in the KQL commands in log analytic workspace to see whether the required data events are coming from Falco. So let's go into the Azure portal. Then if you open Azure portal, then if you go to the subscription, then you can see the components, AKS, the logic app, everything. So if you go to the logic app, because I need to give you some explanation how this works, right? So it's a very simple logic app. It doesn't have much many complex things. So it is a HTTP webhook. So we will configure the webhook in the Falco sidekick. Then it will send the data. There's a connector. Then this data will be created onto the custom log analytic table called Falco logs. Right? So then I will use the log analytic data collector connector to connect with log analytic workspace. Then if you go to the log analytic workspace, then under the logs, right, then if you use the KQL mode, right, then if you type Falco logs underscore CLI, because underscore CLI is automatically appended because it's a custom table. It means CL means custom logs, right? So if you run the Falco logs underscore CL, then you will see many events are exported to the log analytic workspace. Right. So initially there are a lot of logs will be injected, right? But it's good to do a filtration from the Falco and a Falco sidekick side to send the important type of logs or events to the log analytic workspace. There are some false positives as well, like you need to filter the Kubernetes names pods like AMA log agents and those kind of workloads, because they are also generating some events to the Falco. Okay, now what we can do is we can run the simulate attack.sh, right? Then it will create some it will read the shadow file, then the password file, then it will go and access some sensitive items, right? So if you check the simulate sh, you can find the attack pod is creating, right? Then it will read the shadow files and the password file. Then it will read the authorized keys like password, shadow file. So those kind of very simple things you can done for testing, but you can do like very advanced stuff as well. Then based on that you can create different events and incidents to the Sentinel analytic queries. So we will wait until this is completed, or we can go and check the log analytic workspace, right? So if you check last 30 minutes, right, then you can see this is the password read, right? So if you click this one, click the event, you can see it read the password file, rule is sensitive file access, then priority is critical, then output is it will show you critical sensitive file access, and it will give you who accessed the file, which file is accessed, the container ID, then the container name, the namespace the container is accessed, and the image and there are a lot of other details, tag and everything is there. So it's very useful for you to do filtration and things like that. Then you can see the container name is attack, so those containers that we created, and Falco demo attack is the namespace. Okay, now we can see that the date events are coming to the Logantic workspace. Then we will go and check whether the Sentinel has any incidents identified. So if you go to the Microsoft Defender, because now Sentinel is a part of Microsoft Defender, then if you go to the investigation and response, incidents and alert, then you can see the incidents. So you can see there are many incidents are created, right? Okay, let's put it to last 1 day, right? Then you can see it, if you click one of these incidents, then you can see more about this incident, right? You can see the query results. Sometimes those are not loading, but yeah, you can get the idea that you can create incidents in the Falco for the incidents in Sentinel based on the Falco logs. So if you go to this one of this sensitive file access, let's see whether we can see additional data. Okay, yeah. Yeah, those are the incident create based on the detection queries, right? So if you go to the hunting and the custom detection queries, you can see that the 5 Falco related queries that we created previously. Then next I will show you the dashboard that we created to get some overview of the Falco events, right? So the dashboard is named as Falco Security Dashboard. So if you open the workbook, then if you select the subscription, then if you select the Logantic workspace, then you can see different graphs related to the Falco events. Okay, now you can see there are this is a graph that is showing the events based on the priorities, right? So yeah, I'm not doing any filtrations. That's why it shows as increasing. But as I mentioned, you need to do some filtration and identify any false positives, and you need to filter them as well. So here you can see the triggering alerts, right? Triggering rules. So like drop the execute new binary containers, unauthorized processing containers. There are different type of rules that are created in Falco, right? So those rules can be found in Falco values file, right? These are the custom rules I have created, but there are some inbuilt rules that are coming with Falco, right? But it is very flexible. You can create your own custom rules for the Falco. Then you have the top 10 most alert generated pods, right? So you can see that AMA logs pods are one of the most alert generated. That's why I mentioned that we need to make them exceptionals, right? So because these are most of these pods are managed by Microsoft and they access some sensitive items like secrets and those kind of things. So then you can see the recent security events right here. So it's priority and thing. Then the alert generated based on the host also can be seen here. Then top 10 containers by the alert count also shown in here. So this is a very basic workbook, but it provides you some good information about the overall Falco events that are generated. Okay, that's all for this demo. I think this would help for anyone who's like to explore Falco and the runtime security in AKS with integration with Azure Sentinel. So this is a very good way of monitoring and identify any threats within your clusters, right? So it will provide a good overview and provide a insight if someone is accessing any sensitive items or runtime security can be identified through the Falco and Azure Sentinel and Kubernetes. So thank you very much. I will come back with another video like this about Azure Kubernetes, then cloud native tools and open source tool related to DevOps and Kubernetes. Thank you very much. See you later.